Okay, so we've looked at a little bit of the wave technology. We've looked at a little bit of the physics of the waves. 8.4 is wave resources. I guess we even saw a little bit of that, back here. It's sort of the global wave resources. Zooming in, though, a little bit closer to home on, well, at least home if you're British, is what's going on here with seasonal. So the seasonal mean significant wave heights, so these are things that would actually bear some energy. And they're plotting these things in meters, and the font is hard. It's hard to read in the book, and it's even harder to read on the screen, but I'm going to do my best. This dark stuff, and unfortunately, well, I don't know. Unfortunately, these dark purples look a lot like these dark blues, so I think we'll just have to do our best here. So if we look at this guy, let's just start with the yellows, 2.5 to 2.75, and let's focus primarily on the winter. So for 2.5 to 2.75, that's the height. If we move out further, here's the orange, 2.6 or 2.76 to 3.0. So we're moving offshore. And so this is really all they tracked. They sort of took a, and I don't know what, I'm not sure how they got this stuff, whether they did it with buoys or some type of satellite imaging. Break down at different depths. Yeah, I don't think the book really says what technology gathered this. But so in the winter anyway, as we move further out in this direction, we can get up to wave heights of 3.26, so 3.25 to 3.5. If we move even further out in the northwestern direction, we can get up to waves as high as 4 meters. And you can kind of think of this as the leeward side, and this is the windward side of the island there of Great Britain. In the summer, where you might have had 2s and 3s, in the winter now we're looking more down in the 1s and 2s. So just less energy in the air in the summer. I think, I guess it looks like to me this in the spring, what was yellow inland is now yellow further out. So the spring are actually getting, in general, better, better resource down here. Not quite as much out in the northwest as you are in the winter and the autumn. Slightly better here than you did in the winter, at least in a few spots. Okay, and what do you do with that data? Well, you run your cost analysis. You say how much power is there. Well, then that's how much energy is there, and how much money is there, and how much money do I have right now to spend to get that energy later. Okay. Now, table 8.2 says that the natural and technical wave energy resource. So the natural is what's sort of sitting out there in nature. Technical is what can I actually build to harvest it. Well, let's just start at the shoreline. So at the shoreline, the average natural resource, we're looking at 30 gigawatts. And that's not really a whole heck of a lot. 30 gigawatts, that's enough electricity for, it's 30 billion watts, so it's enough for 30 million households. I mean, it actually, you know, if you did the whole thing, it might be enough to run the entire island, but then you've got your entire shoreline covered with wave tech. Converts it to terawatt hours per year. But then if we look at the technical resource, gosh, it's actually less than 10%. No, in fact, it's less than 1% of the natural available. Moving out to 20 meters, there's more energy out there, as we just saw, as we were in fact seeing here on the screen. You move further offshore, there's just more energy out there. And you've got about a 4-to-1 ratio or a 5-to-1 ratio. There's 5 times the natural as there is technical. You move far enough offshore out to 100 meters, and it sort of flips. So there's sort of a sweet spot there at a depth of 20 to 40 meters, where you're not so close that the waves are small, you're not so far that it's hard to get to. So looking, 20 to 40 meters, it's kind of your sweet spot for harvesting energy. And 87 terawatt hours per year, not too bad. Okay, let's call it right there before we get into some of the wave energy technologies. There's a bunch. They're not quite as wacky as all the wind technologies, but kind of fun to look at. We'll take a look at those on Thursday. All right, so yeah, I think we'll be able to finish this chapter Thursday. A couple more weeks, a couple more chapters. Santa Claus comes.
This mall is not charging people to visit with Santa Claus this year.
What? The mall is charging?
Not charging. No, there's a certain mall, I think it's in New York. that
Oh.
charge. If you sit with Santa Claus, you're forced to pay for a picture package, and it's like, you can keep your Santa Claus. I'll go to Albertsons and get a free picture.
Yeah.
Things people do in different states. We'll see you later.
Okay, bye, Sean.
Have a safe ride home.
I will, thanks. I'm actually driving Boris.
Is that energy, that building energy class, is that going to be online or is that?
Well, it's both. I mean, it's just like this class.
Okay.
Yep, just like this class.
Is that, I don't know how many days we'll be able to do lectures and stuff for that.
It's not a big deal. Yeah, we'll have students. I think there's 5 students in this class, and not everybody comes every day. So, yeah, I mean, really, we're trying to embrace the 21st century education model where we just make it available. And
That's nice.
yeah, and there will be, in the past with building energy efficiency, we've always had a home tour or two.
Okay.
There's like a blower door day. So we do a little bit of hands-on, and I might even, like I said, I'm going to go to the bank here and to the Five Valleys High Performance group and put a proposal together. I mean, I would really love to see my home become a net positive house. I think there might be a couple around here, but in exchange, I would like to just open it up to the public and say this is how you do it. And then for me, sustainability is, well, Missoula Federal Credit Union, loans me the money. I give the money to the renewable energy contractors. They put the work in. In the long run, I don't have an electricity bill. I don't have a water bill. I don't have I'll still have a food. I don't think you can grow enough food on my little plot, but I would love to have, less of a food bill. I don't want to have a natural gas bill anymore. I'd like to be able to make all of those things rather than consume them. That's like my crazy man goal. But the sustainability I see is like, if I'm able to pull it off, then other people say, oh, it wasn't easy, but what the heck, Layton did it, and then the bank then puts more money into that, the the energy tax and the SBSs and all of these renewable firms get more, it should perpetuate. That's where I want, I mean, where else can we go, man? I mean, we can't just keep burning the joint and expect the few to get rich and the many to get poor. I think we have to go there. So I'm putting a lot of faith in the bank, and I'm putting a lot of faith in this little Five Valleys High Performance Building Consortium, and I'm willing to martyr myself and martyr my home. If it doesn't work, then we all go down together. But if it does, then I think it makes a brighter, brighter future for everybody. So we'll see.
I saw something. I think I got a newsletter from this little Federal Credit Union